Hello, students all over the world. Once again, you are welcome to our series of lectures on complex numbers. I am your lecturer, Professor Efan O. Efan. This is our third lecture in this series. In this lecture, we shall be dealing with 1. Argan diagrams, and 2. Modulus and argument of complex numbers. Argan diagrams. An Argan diagram is the graphical representation of a complex number. In a rectangular coordinate system, the complex number z equal to x plus iy is represented by the vector xy. A rectangular coordinate system consists of two intersecting straight lines. One is horizontal, called the x-axis. This is the x-axis, while the second is vertical, called the y-axis or the imaginary axis. The two lines intersect at a point O called the origin. Now, to locate the point xy on this plane, we have to measure its distance x from the y-axis and its distance y from the x-axis. Where these two lines meet represent the point xy. Now, our complex number z equal to x plus iy is represented by this arrow. The arrow emanating from the origin and terminating at this point xy. The whole of this diagram is what we refer to as the Argan diagram. Modulus and argument of a complex number. Let the complex number z equal to x plus iy be given. This can be represented on the Argan diagram as shown earlier as follows. On this Argan diagram, the distance from the origin to this terminal point is what we call the magnitude of this vector, or the modulus of the complex number z. And this is written as r equal to the modulus of z. This is the symbol for the modulus or magnitude of the complex number. While the angle between this vector and the x-axis, I'm referring to this angle theta, is what we call the argument of the complex number z, and we write this as theta equal to argument of z. Now, to calculate the modulus of a complex number z, we notice that this is a right angle triangle. Then by Pythagoras theorem, r squared is equal to x squared plus y squared, giving us r equal to the modulus of z equal to the square root of x squared plus y squared. Also, in this triangle, this is the opposite side to this angle, while this is the adjacent side. Then we can calculate the argument theta by taking tan theta to be equal to y all over x. If tan theta is equal to y over x, then theta is equal to the argument of z, which is equal to tan inverse y all over x. Please note here, we are assuming that both x and y are positive. Let us take note of the following. 1. If the argument theta is greater than 0 degrees, but less than 90 degrees, that is if it lies in the first quadrant, then theta can be calculated by using the formula arctan y all over x. 2. If theta is greater than or equal to 90 degrees but less than or equal to 180 degrees, that is if theta is in the second quadrant, then the argument theta is equal to 180 degrees minus arctan, the absolute value of y all over x. 3. If theta is greater than or equal to 180 degrees but less than or equal to 270 degrees, then the argument theta is equal to 180 degrees plus arctan, the absolute value of y all over x. And 4. If theta is greater than or equal to 270 degrees but less than or equal to 360 degrees, that is if theta is in the fourth quadrant, then theta is equal to 360 degrees minus arctan, absolute value of y all over x. Example 1. Let z equal to 3 plus 4i. Then the modulus of z, r, is equal to the square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. So this is equal to the square root of 25. And square root of 25 is 5. So the modulus of this complex number z is equal to 5 units. Now, to calculate the argument, we have to sketch the diagram, the Argan diagram, as shown here. So we observe that from this Argan diagram that our argument theta is in the first quadrant. That is, it is less than 90 degrees but greater than 0 degrees. So therefore, theta is equal to arctan 4 over 3. That is, y is 4, x is 3. Arctan 4 over 3 is approximately equal to 53 degrees. Example 2. Now, let z equals to minus 3 plus 4i. Then, the modulus of z, r, is equal to the square root of minus 3 squared plus 4 squared. Minus 3 squared is 9, 4 squared is 16, so 9 plus 16 is 25. So this will also give us square root of 25, and this is equal to 5. So the modulus of that complex number z is also 5 units. Now, to calculate the argument of z, we obtain the Argan diagram as shown here. Observe that in this Argan diagram, that this is our argument theta. This angle is greater than 90 degrees but less than 180. So therefore, we have to calculate arctan of the absolute value of minus 4 over 3. Here y is 4, x is minus 3, so that will give us minus 4 over 3. Absolute value of minus 4 over 3 simply tells us to ignore the negative sign, and this is equal to arctan 4 over 3. And arctan 4 over 3 is approximately 53 degrees. So therefore, our argument theta is equal to 180 degrees minus 53 degrees. 180 minus 53 is equal to 127 degrees. So that is our argument theta. Example 3. Now, let z equals to minus 3 minus 4i. Then, the modulus r is equal to the square root of minus 3 squared plus minus 4 squared. Minus 3 squared is 9, minus 4 squared is 16. 9 plus 16 will still give us 25 as before. So this is equal to the square root of 25, and square root of 25 is 5. So the modulus of this complex number z is equal to 5. Again, to calculate the argument, we need to obtain the Argan diagram of our complex number. So observe that the complex number this time is in the third quadrant. That's our argument. Theta is greater than 180 degrees but less than 270 degrees. So we have to first calculate arctan absolute value of minus 4 over minus 3. That is y all over x. So absolute value of minus 4 over minus 3 is the same thing as 4 over 3. So that will give us arctan 4 over 3, which is approximately equal to 53 degrees as before. So therefore, to obtain the argument, theta is equal to 180 degrees plus 53 degrees, which is equal to 233 degrees. Example 4. Let z equals to 3 minus 4i. Then the modulus of z is equal to the square root of 3 squared plus minus 4 squared. 3 squared is 9, minus 4 squared is 16. 9 plus 16 will still give us square root of 25. And square root of 25 is equal to 5 units. So that is the modulus of this complex number is equal to 5. Again, to compute the argument, let us have the Argan diagram as shown here. Here is the Argan diagram. Observe that our vector this time is in the fourth quadrant. That is, this angle theta is greater than or equal to 270 degrees but less than or equal to 360 degrees. Again, we have to compute arctan inverse absolute value of y all over x, that is minus 4 over 3. And absolute value of minus 4 over 3 is 4 over 3. So this will give us arctan 4 over 3. Again, arctan 4 over 3 is approximately equal to 53 degrees. Therefore, to obtain theta, which is in the fourth quadrant, we have to subtract it from 360. So theta is equal to 360 degrees minus 53 degrees. And this is equal to 307 degrees. We have come to the end of lecture 3. Thank you for watching and keep on watching. I remain your lecturer, Professor Efa O. Efa.